today we're going to solve polynomial functions. So we're going to kind of put everything together. I'm going to come back and look at homework answers at the very end. But remember yesterday we were looking at the difference between long division and synthetic division, right? So which one do you guys like better? I like both. I mean, they both work. Can somebody please raise their hand if they can tell me why we use synthetic? Or when we use synthetic, I should say. Let's give about 5 seconds of thinking time for that one for a second. Thinking time means you're not talking. Welcome, Essence. Okay, Noelia. You don't have a coefficient, right? So can you guys give me an example of when not to use? Since Noelia said it. Yes. 2x minus 3. 2x minus 3 would not be a fun one to use synthetic division, because you'd have to divide by 2, right? Because then we'd have x minus 3 halves, and that wouldn't be very fun, right? So there is, and who was asking me? Oh, Cameron was asking me about, on a test, if you have to use one or the other. I'm going to put on the test 2 different problems. One of them would be you could easily use synthetic division, and one of them is not going to be easy to use synthetic division, because I want to be able to assess if you can use both. But I wouldn't penalize you if you've never used synthetic, okay? Because if you like long division, use long division, okay? Synthetic is just an alternate that can, help you out, and it's a little bit easier. All right, so let's compare and contrast the 2 of these. So why don't you guys practice a little bit? Get your markers out. You can write right on your desk. And I'm asking you, yes, ma'am. I'm asking you, is x plus 3 a factor? Now think for a second. Whenever you think about it, think about what we did yesterday. Cameron, yes. Hold on. Think about what we did yesterday. And what I'm asking you is x plus 3 a factor? How would we determine that? Just think about it. Okay, somebody have an answer for me? Anybody have a guess? Let's hear it. Okay, how would I know if x plus 3 is a factor? Based on what we did yesterday. Mama? Okay, did you guys all hear that? No. We could use long division or synthetic division, and if we get a remainder of 0, then we know it's a factor. So we could test it. So today and Monday, for the rest of this unit, is basically going to be testing. So you got to get really good at that synthetic division or the long division, okay? Because it's going to be crucial, okay? Because you're not going to be able to eventually we're going to factor this thing all the way down. And then once we factor it all the way down, what do you think we can do with that? We can graph it, right? We can find the x-intercepts and we can graph it. So we can actually, we're going to the highest level that we can with polynomials. Okay, because ultimately this is a graph. I've got a question for you. What's the y-intercept here? How do we know? Because if I were to plug in 0 for all of those, I would get, so we already know we can plot 1 point on our graph, right? Okay, so if I want to determine whether x plus 3 is a factor, then I would use negative 3, correct? Because if I set x plus 3 up to 0, I would get x equals negative 3. Okay, so I'm going to try it. I'm going to use synthetic because it's easier. So I've got negative 3. And my coefficient here, let's double check, 3, 2, 1, none. Do I have any holes? So we're good. Okay, so my coefficient here is 1, 6, 11, and 6. I set it up for you. You go ahead and do it. pausing? Okay, so my first step, you guys did a fantastic job. I'm going to dash it. I like that better. It kind of like lets me know that that's the end of my problem. All right, so I bring down the 1. Negative 3 times 1 is negative 3. 6 and negative 3 is 3. Negative 3 times 3 is negative 9. 11 and negative 9 is 2. Negative 3 times 2 is negative 6. I did, in fact, get a 0. Therefore, I know that x plus 3 is a factor. Okay? So why don't you guys go ahead and do this one completely. Set it up and do synthetic division. So now you have my example here. Yes, Essence? We're going to get there. Right now, we're just testing to make sure, but the answer to that question is going to come, Essence, in about 5 minutes. Okay? I'm going to go ahead and pause recording. Okay, so we're going to check and see if negative 3 is a factor. And so I have a coefficient of 1, negative 6, negative 13, 42. What did I not do? I should always check what? If there's a gap, if there's holes. So 3, 2, 1, none. We don't have any gaps, so we're good. All right, so I'm going to bring down the 1. Negative 3 times 1 is negative 3. Add those together, and I get negative 9. Negative 3 times negative 9 is 27. Help me, it's Friday. 14. 14 times 3 is? Negative 42, and we get a 0. And so, yes, in fact, x plus 3 is a factor, which means negative 3 is a what? Not a factor. It's a 0. What else can we call that? A root. What else could we call it? An x-intercept. Excellent. Excellent, you guys. Okay. So this is what we got, right? Now, let you take a look at that for a second. What do you mean, yeah, right? Where did I get these numbers from? Where did I get that trinomial from? Shaden, that better not be a phone. He looks worried. I'm good. Oh, just because you put your hands in the air doesn't mean you don't have a phone in your lap right now. Okay, so where did I get that trinomial? Let's look. Let's look at this. Let's go back to this. Remember I told you, so we know that x plus 3 is a factor, right? Then from here, I can see, do you see the trinomial in there? It's right there in front of you. This would be the constant. This would be the coefficient of x. This would be the coefficient of x squared. So I have x squared plus 3x plus 2. And over here, I have x plus 3 is a factor, and I'm left with x squared minus 9x plus 14. Bryce, you're not even looking up here. You were like, that's crazy, and I just showed you how to find it, right? Do you see it? Do you see it? Do you see it? Okay, so it's not so crazy. Okay, so from here, we're not done, right? Okay, hold on, I want 5 seconds think time, and I'll tell you when to stop, and then I want you to talk with your table groups on where I go from here. So 5 seconds, no talking. Okay, talk about it. Where could you go from here? I want to factor this thing down completely. Well, I just said talk to your group, not to me. reach into that toolbox that you've had since the beginning of the year. I told you were going to use everything we learned. We're going to use it all the way up until the end. Okay, 5, 4, 3, 2, 1. I forgot to pause, but that's okay. So this video is going to be a little bit longer. All right, so anybody have an answer for me? Okay, Kane, what could you do? I could factor this trinomial, right? So I have x plus 3. Oops. A little eager there, right? X turns into x times x, and the factors of 2 are 2 and 1. Let's do rainbows and checks, so 2x and 1x makes 3x, which is our middle term there, right? So I just factored that all the way down. What if it wasn't, what if I couldn't easily factor it? Do I have another strategy? Long division. You're absolutely right, but we're going to get there because you can't just say long division because we've got to have some other strategies in there. But go back to factoring. What other strategies do we have other than factoring? That's factoring. Box method is factoring. Square rooting, if you have only 2 terms. Completing the square, right? One of my favorites. Quadratic formula, right? All of it, you could use all of it, right? That's, right, I could use the quadratic formula, a, b, and c. Negative b plus or minus square root b squared minus 4ac over 2a. Okay, so this one's also, is this one factorable? So x plus 3, x and x. What are my 2 other ones? 7 and 2. Does 7 and 2 make make negative 9? Joey? Does 7 and 2 make negative 9? So we need them to be negative, because negative 7 times negative 2 is positive 14, but when you add them, you get negative. We have to add them to get the negative 9. So negative 7x and negative 2x make negative 9x, right? If I were to FOIL it, go in the reverse direction. But negative 7 times negative 2 is positive 14, so we know it works. Okay, so what did I just find? I found all the x-intercepts, or the roots, or the zeros, right? Okay, I could graph this now, correct? Okay, show me with your hands what this graph looks like. You guys are so cute. Yes, it looks like this, right? What if it was negative? Look like this. Good. Okay. We can do the factor dance on Monday. How about that?
Today's Friday.
Okay. Yes, thank you, Bryce. I appreciate that. All right, so if my zeros are negative 3, negative 2, negative 1, and I know I have an my y-intercept is right there, it's positive 6, I could roughly sketch this, right? I don't need any numbers, I just want to do a rough sketch. So it's going to look like that. This one, I have negative 3, a 2, and a 7, and what's my y-intercept? 42? Okay, well that's way up there, right? I know I have to start in the first quadrant because it's positive. So we got something like that. So that's all I need on your homework, is just a rough sketch. We just want to connect the graphing portion to the actual algebra, right? Okay. Look at how much you guys have learned. You guys have learned so much. Wait, I think I had a question on here that was important. This is my most important question right here. And this is going to require some thought, okay? And I thought long and hard about how I was going to teach this, and I'm teaching it very non-traditionally. Do you see any because it makes more connections when you teach it non-traditionally. If I just sit here and tell you, that doesn't teach you, right? That's just me telling you. If you guys have to think about it and struggle with it, that's where we make some connections, right? Okay. Speaking of connections, do you see any connections with the zeros and the original function? So look at the zeros and look at the original function. We're going to go even 20 seconds of just thought. Okay? Look at the zeros and look at the original function. There is a connection there. You can pull something out of it. So just think about it. Just think. What'd your group come up with? Yes.
On YouTube.
Yes, on YouTube.
Hi, shout out on YouTube.
Please subscribe to Mrs. Mahler's channel, right? Okay. Did you guys come up with any connections? Okay. Llama? Oh, hold on. I want to hear Llama. Yes. There's a connection. Cubed, right? That's how many zeros. Is that always going to apply? Why not? Gene, why not? Half? Okay, Malik. There could be a double root. Why else? Kane? We don't call them fake. Imaginary roots. We can have imaginary roots, right? Awesome. You guys are amazing. What other connections did you see? All right, let's hear it. Jay. Uh-huh. Okay. Well, okay. I'm going to stop you there. Well, I'm not gonna go against your connection, but I'm not sure that it always holds true. Okay. Kane, you got another one? When you multiply the zeros, they give you the opposite of the y-intercept. I don't know about the opposite stuff, but I'm always learning as a mathematician. But you are onto something. Okay, you guys see that? You see that, okay, they all multiply up to it, right? I'm not going to say that's always going to happen, but I will tell you this. Well, it is always going to happen, right? I'm trying to think. To zero, you're right. But when we start from scratch, if I were to start from scratch and I didn't give you any zeros, right, you don't know what they are. Because with 6, it's kind of easy. The only factors of 6 are 3, 2, and 1, correct? Is 3, 7, and 2 the only factors of 42? There's lots of factors of 42, right? But it gives us a starting point. We know that there's got to be, that this number right here, these numbers have to come from this, correct? Well, let's try and figure it out. Let's look at this one. I don't have any zeros. I have nowhere to start. So what would you try? What would you try? What? What zeros would you try based on the fact that you could try plus or minus 2, right? You could try positive 2, you could try negative 2. What else could you try? You could try positive or negative 4. What else could you try? Positive or negative 1. Look at that one. What could you try here? That one's easy, right? This is where synthetic division comes in very handy because you can do it very quickly and figure out if those are zeros. plus or minus, let's start with the most simplest. 1, then what? 3, then what? Is that it? So those are all my possible zeros. Good job, guys. Let's try another one. You guys got it. Plus or minus 1, 2, 4, 8. Well, that's not all we're going to do. That's the beginning, okay? So I really want to get you guys working. I don't think we need to go anymore. Now here's the beginning of our lesson. We just started. But we've done all of the hard work, right? Now I really want you guys to get working. So how much time do we have? 20 minutes? So I'm going to talk for 5 more minutes, and then I'm going to get you guys working. Right, Joey? Okay. So let's take the hoodie off. Hoodie off. And let's remove the pillow arm. Okay? All right. So students will be able to solve polynomial equations using the rational zero theorem. That's what we were just using right now. That's the rational zero theorem. That's where I was finding the possible zeros. Okay? Just a fancy word. All right. And we're going to get more in depth in it on Monday. All right, so my possible zeros. Okay, so this is pencils down. I know I don't have it up there, but I need everybody quiet. Pencils down. Just watch it. This is number 1 on your homework. I'm going to give you a chance to copy it down. So plus or minus 1, plus or minus 3, plus or minus 9 are my possibilities. I know this is x cubed. I also know that I have a y-intercept at -9, something like this. I know it's going to look like this because it's a cubed function, cubic function. So I'm going to try 1 first. So I've got a 1. Oops, that doesn't look good. And that's not normally how I do it. And I have 3, 2, 1, none, so we're good. So I have a 1, coefficient of 1, coefficient of 1, -9, -9. I'm going to bring down the 1 times 1 is 1, 2, 1 times 2 is 2, -7. Is this going to work out for me? I'm not going to get a 0, right? So I immediately erase it, and I'm going to try -1. As you get better at this, you'll start seeing it as you're going, and you'll be like, nope, that's not going to work. Okay? It seems like a lot of work, but you'll get better and better and better. It just takes practice. Bring down the 1. 1 times -1 is -1, 0. -1 times 0, 0. -9, you see it? It's coming. -1 times -9 is +9. So now I have a factor. What's my factor? Not -1. X plus 1 is my factor. What's my 0? -1. So x plus 1 is a factor. When I take that factor, this is the rest of my, I should have done that in a different color. Give me a second. Green. Green. Why is it not going green? Okay, try that again. Not my luck today. Just do it over. Okay, so x plus 1. And what I'm left with is my -9. That's my constant. I have there's no coefficient for x, so there is no x, right? So that means this one right here is x squared, correct? Because this would be 0x, and this would be x squared. And then I go, I'm so excited right now. Why am I so excited? It's the difference of 2 squares, right? Yay, it's so exciting. You're like, oh, it's like Christmas, right? I don't have to do any more work. I don't have to do any more synthetic division. I just scored, right? So my factors are x plus 1, x plus 3, x minus 3. Okay? You could have started with what? 3. You could have started with -3. You could have started from the back and worked your way this way, okay? It just so happens since we started with -1, we scored and had the difference of 2 squares, okay? Yes? It'll unfold itself. Yes? No, we wouldn't have. If we would have done, look, this would answer your question right now. If we would have done 3, that would have been this factor, right? That's such a good question. I'm going to explore it right now. If we would have just done this, we would have found that factor, then you would have got the trinomial. I'll FOIL it for you right now. X times x is x squared. 1 times 3 is 3. 1x and 3x is 4x. You would have got this trinomial, and then you would have factored it to this. Make sense? So we scored by coming up with the x plus 1 because then we could easily factor that one without even thinking about it. Oh, look it, I didn't lie. I think we're good. I'm just going to graph it. So I've got -1 is one of mine, -3 and +3. Does that make sense? It's consistent with what I already thought, right? And we're good. All right, I'm going to pass out your homework, and I'm going to let you go ahead and copy that down. My zeros, I'm going to write them in set notation. My zeros are -1, 3, and -3. And my y-intercept is 0, -9. All right, I'm going to pause it. Okay, so let's look at number 2. So since we have no constant, we know our y-intercept is 0, 0. So that's the first piece of information I have. There's another piece of information I have just by looking at it. It's not. What type of function is it? It's cubic. No, not quadratic. It's cubic. It's cubic, so I know it looks like this, right, essence, because it's positive, so I know it's going to start in quadrant 1 no matter what, right? There's another piece in there. Can you pull out a GCF? You could pull out an X. If you believe. You don't have to, but you could, right? I could pull out an X. Isn't that our number 1 go-to with everything when we're factoring or trying to find factors? If you can pull out a GCF, that's your best bet. So I'm going to pull out a GCF. When I pull out a GCF, I have x. What's remaining? X squared plus 2x minus 15. Oh, looky there. Do I need synthetic division for this? No. Factor it. You guys do it. Factor it. Joey, factor it. No. Forget about this, Essence. It's not there right now. It's non-existent. It's not part of my problem right now. I don't need it. That's algebra 1 right there. Right? Don't make it too hard. You know how to do this. You guessed. Okay, that's enough time. Help me, Essence. X and X. What two numbers, when I multiply, I get negative 15? 5 and 3. And you're saying that which one needs to be negative? If I have a negative 5, I have more negatives than I do positives, right? That's not going to make it a positive. Negative 3. There you go. Right? Good job. And we originally had an X out here. So I'm completely factored. Andrew. Not you, Andrew. Andrew. Give me my zeros. Not only negative 5. Because really, what is this? If I really wanted to make it look like that, it's x minus 0, right? So I have a 0, I have a negative 5, and I have a positive 3. I already plotted my 0, 0, so I'm going to plot my negative 5 and my 3. There's my sketch. So how many more do you have to do? Not a lot. Okay, well, you have 7 minutes. Get to work, and if you get stumped, I can help you on them, okay? Or in 2 minutes, pick the hardest one, and I'll do it. I want you guys to work for 2 minutes first, though. Pausing. 3, 2, 1. Okay, so with this one, number 4, I see, hey, I've got x cubed minus 8 equals 0. I have something in my bag of tricks I can work with that. Mama, move the 8 to the other side. X cubed equals 8. Not square root each side. Cube root each side. Right? You should see there's 2's in there. Like Gene said, he's like, I see 2's. And so when I do that, right, I get nope. Correct? Yeah, you can cube root something. Right? As long as you do it to both sides, as long as you follow the laws of mathematics, if you do it to one side, you do it to the other. Right? If it works out that way. If it doesn't, what could I do? Could I use long division? I could. Synthetic. I could use synthetic. What would I test first? Plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. You can go that route. You're going to get the same answer. Okay, so you said what, 6? Oh, I don't have 6 in here. Here's a good one. Let me get to my closure. No, hold on a second. They'll be in the video. Okay, what did we learn today? How to solve it all the way through, right? How to factor something all the way down, because we have all types of methods now. Okay, what do we know when we get a remainder? It's not factorable. Good, you guys, that's from yesterday. Okay, so compare and contrast these two. This one's factorable. This one's not, so what's it going to look like? It's going to have imaginary roots. Good job, guys. Pack it up. Okay, hold on. I'm going to stop my recording and then I'll take questions.